Welcome back to Blueprint to Reality. Today, we're taking a closer look at one of the most critical parts of any skyscraper, its foundation. How do these massive buildings, some reaching over 1,000 feet, stay upright without sinking or toppling over? The secret is in the engineering of the foundations. Let's break it down. The basics of foundations. Foundations are essential for distributing the enormous weight of a skyscraper to the ground beneath. But it's not just about supporting weight. Foundations also help skyscrapers resist forces from wind, earthquakes, and even the shifting of the earth itself. There are two primary types of foundations used for skyscrapers: shallow foundations and deep foundations. For small buildings, shallow foundations are usually enough. But skyscrapers? They need something much more robust. Deep foundations explained. Skyscrapers rely on deep foundations, which go far below the surface, to find solid ground or bedrock. The most common types are piles and caissons. Let's start with piles. Piles are long, slender columns made of concrete, steel, or even wood that are driven deep into the earth. These piles either reach bedrock or are driven into dense layers of soil that can support the building's weight. The goal? To transfer the load from the skyscraper down to a stronger, more stable layer of earth. Next, we have caissons. Imagine caissons as giant, concrete pillars, almost like enormous, buried columns that reach bedrock. Workers excavate deep shafts, fill them with concrete, and voila, you've got a super strong foundation. Challenges of building foundations. But it's not always easy. In cities like New York and Chicago, where skyscrapers are everywhere, engineers have to deal with unpredictable soil, water tables, and nearby structures. Sometimes, they use a technique called friction piles, where the friction between the soil and the sides of the piles helps support the weight of the building. Another key challenge is settlement. Settlement happens when the soil under the foundation compacts over time. If one side settles more than the other, the building could tilt or crack. Engineers have to design foundations to minimize this uneven settlement. How foundations resist external forces. Now, skyscrapers aren't just sitting on the ground. They're battling natural forces like wind and earthquakes. This is where the foundation really shines. Wind. The foundation anchors the entire structure, preventing it from swaying too much. Engineers even build in flexibility, allowing the skyscraper to move slightly without causing damage. In earthquake-prone areas, the foundation often has to absorb seismic energy. Engineers use flexible materials and base isolators in the foundation to cushion the impact of an earthquake, reducing the stress on the building itself. Real-world examples. Some of the world's tallest skyscrapers have incredible foundations. Take the Burj Khalifa in Dubai. It stands over 2,700 feet tall and has a foundation that extends over 160 feet into the ground, made up of reinforced concrete piles. Then there's the Shanghai Tower, which uses both piles and caissons to deal with the soft soil and seismic risks of the region. Its foundation is built to withstand high winds and potential earthquakes. So, how do foundations support skyscrapers? By reaching deep into the earth, anchoring the building to solid ground, and resisting the natural forces that could bring it down. Without these marvels of engineering, the towering skylines of cities around the world wouldn't be possible. Thanks for watching Blueprint to Reality. If you enjoyed learning about the engineering secrets of skyscraper foundations, don't forget to like and subscribe. See you in the next video.